Hi,
Hello,
here is Olie and
Peter.
Peter. Not Peter.
Peter.
My name is ruined. Not Peter is a virus, so I'm Peter. Peter. Um, right. What do we do today? 3 months later. Yeah, we were busy. So many things happened, as usual. So what we do, we try to do operators how is it? Precedence. Yes. So we want to add multiplication. I have to be honest with you. It wasn't that easy to immediately go back to this code. So I added multiplication beforehand 2 days ago to at least check if I still can code JavaScript. Yeah, I can. So we can do it today. Where do we start?
With multiplication.
Yeah, just a little bit of beer. 3 months into isolation, and now we can actually record the screencast together. We sit next to each other. This is it's a treasure. So okay, let's start with just adding multiplication. This is the multiplication edit. I think that's it, right? Done. No, we need to run the program. Okay, let's do it. Oh, it complains cannot use import statement outside module. Yeah, I remember why. Because to run tests, we had to change the type of our module. Type what? Type. What should it be? Type module. Okay, module. Smart. The module and the type of the module is module. Wow.
Syntax error.
Yeah, and now we have our own syntax error because unexpected character star. Ta-da! That means if it's a syntax error, it's in our lexer. So lexer doesn't recognize this character, and let's see where it is. As you remember, we have this magical source file notation here, so we can command click. And ta-da, our language parser gives us precise code locations. Da-da-da-da. Isn't it cool? It is.
It is.
Yes.
Definitely.
So it cannot lex or scan the multiplication. Easy. This is easy part. We just need to teach our lexer to parse multiplication. And we already have this function operator. I don't remember why we have it, but it's readable. So actually, as we're coming back to the code base, which I haven't seen for 3 months, it is not anymore my code. It's the code of my previous self. So I respect my previous self. Operator nicely grouped things, so I expect that my previous self expected us to just add another if here. So say if it's multiplication, then we do exactly the same because it's a single character token, and then we do, instead of plus, we do mul token. That's it. And I save, and let's see what parser will tell us. And parser tells us that it expected some other token end of file but got mul token. Interesting. Why does it happen? I believe it happens, again, judging by the gut feeling. I think it is because our plus parser sees number, then it sees plus, then it sees number again. And when it sees number again and doesn't see the plus, it gives up parsing the binary expression. So it folds it. And then nothing else matches multiplication. That means for our parser, it should be the end of the program. Because the parser has no tools to parse multiplication. That means this is it. It needs to just have the verification from the token stream that this is the end, because we want the parser to be precise. It parses either everything or nothing. We still parse half into the program, and we can produce a significant error message, but that's it. So, cool. We know that it's somewhere in the parser. And let's click it again. I just love clicking it. Now it is a it is an error message, not from the lecture where it's obvious what is the current character, but it's now error message from a parser which operates on tokens. So every token has its source location address. All right. So parser, binary tail, yeah, binary expression. Okay. What do we see here? Yeah, easy. We in the binary expression tail we only parse plus token, but no mul token, right? Easy peasy to fix. This is the first step I would do. First, it's not anymore plus. It's an operator. It doesn't change anything. Still the same syntax error. Good. Let's do then plus token and see what it does. Plus token is a maybe parser. So it tries to find a plus token. If it can, it consumes it from the stream, calling next, and returns. If not, it returns undefined. This is fine for us. We need also mul token of the same. It's a helper function, readable one. So we do mul, and we say that it should be mul. Good. Then we jump back, and what we say that we want plus token or you see, yeah, it's readable. So again, thanks for the Haskell book, some book of Haskell. I don't code Haskell, but as people say, if you learn a little bit of Haskell, you become a better programmer. I can say that I'm very much better, but still this DSL-oriented programming style is very much readable. So here we say that operator can be plus token or mul token, and it's expressed in just JavaScript code, and you can read it and you understand it. Okay, if you know that this thing is DSL, then you can interpret it literally. Super good. All right, it parses. And this is an unreadable mess, I know, but I'll guide you through it. Only now it's time to spot the problematic part. So we see that our source is a binary expression of a binary expression of a binary expression. Yeah, this is only 3 of this. So actually probably this is the first binary expression. Then if we put parentheses around, this is the second binary expression, and this is the third. As you can see, it all starts one after another, so probably it is actually exactly how it sees the code. So it's binary expression numerical 1 plus numerical 2. Then it's a binary expression with multiplication. On the left it's a sum, so I'm correct. And then it's multiplication as the operator, and then it's numeric 3. And then the whole thing is added plus token to a numerical 4. Looks cool, but this is not how we wanted to parse it. We wanted to parse first the multiplication, then the plus, and then the whole thing. And this is where we want to tell somehow our parser, hey, when you see a multiplication, do something, some magic. I've checked TypeScript parser. They use precedence, like really a table with precedence. and then judging of if it's the same precedence or higher precedence, they enable different parsing mechanisms. Also fine for me, but I'd like to continue with this functional style and express it in some functional way. So, what can we say about our binary expression? So currently, it doesn't see the multiplication token as something which is nested into a plus token. So sum and minus, summation and subtraction is a wrapping expression for multiplication and division, as I see it. How to express it, it's a second question, but this is how I see it, at least. Here, when I tried to implement it last time, I kind of stopped for 30 minutes and I was staring at the code, so that you feel that I do it the same way this time. I still don't immediately remember how to solve the problem, so let's just try to think, and I'll swallow some beer, alcohol-frei. German beer, very nice. So currently we have only binary expression and binary expression tail, and tail is recursive call, so it calls itself. I believe we should split it in two things: sum plus expression, which can parse a numeric literal plus and some magic, and mul expression, multiplication expression, which can parse numeric literal, multiplication, and numeric literal, because it will be a kind of leaf type, while some plus expression is a node, so it has a child for mul multiplication expression. So, naming, as usual, the second hard thing, right? Always the first hard. Naming things and caching and naming things, and what else? Race conditions. Race conditions, yes. So naming things. The binary expression is anymore not a binary tail, at least. It should be, in our case, just plus expression. Let's make it plus so we can read it. It parses plus, it does numeric thing, it complains if it's not right, and it returns. It creates the left token, and then it returns the recursive call, so it just parses everything. And now we will have the same error as before. Now what we do? We want to create a clone of it, which only parses multiplication instead of plus. A lot of copy paste, yes. I promised you that we will probably create some again, yes, as usual. I'm very bad at copy paste. Somehow, I promised to create some factory functions which will create these things, but not now. Throw new expected token end of file again. Okay, so mul expression is not used anywhere, and what we should say that multiplication expression only knows inside of it about multiplication expression. So what I want to say, that plus knows that it consists of plus and multiplication, but multiplication knows only that it consists of multiplication because it doesn't care. It just needs to know how to fold itself into one node and give it back to the plus. And that's it for us. So it's kind of regular expression. We discussed it just before the video. It's folding, again, folding of folding of folding, and this thing just folds these tokens, this sequence of tokens in one node, and then gives it back to the plus, so plus can then make a binary expression of a binary expression. Good. So what we do? First, we define multiplication as a thing in itself. So it doesn't know and doesn't care about anything. It's a very selfish matcher. It only matches multiplication. If not, it does nothing with the token given as the left operand. And then if it succeeds, it creates a binary expression and continues to try to parse another multiplication. That's it. So it's the simplest one. But the plus cannot have such a luxury of not knowing about multiplication. Either the outer function needs to know about it, or this thing itself. So first attempt was to not teach plus about multiplication, but teach the function which calls plus expression, and then probably try to match multiplication when plus doesn't know, and it was really hard to read. And actually, I didn't succeed with some test cases. So let's do it the simplest way, which is we put multiplication inside of the plus. Oh my god, how to do it? Actually, I don't remember. So yeah, we have plus expression, and then the plus expression checks if the right is numeric literal. We have it. It's really good, but we cannot just return another plus. Here should some magic happen. Magic happens here. So the plus expression always consists in our simple language version of a number plus and a number. But now this number can be glued to a multiplication. That means that this can be just a normal plus, just a normal 2, or a 2 with an asterisk, a star operator on the right. That means we cannot just use right as right. We must check if right is a multiplication expression. So we give the mul expression a chance within the plus expression to fold whatever it thinks reasonable to fold. In our case, it will add this token and this token in one node. When it's done, it's really easy. When you read this code, you think, yeah, it's like NP problem. When you have a key, NP full, NP complete. When you have a key, it's super easy to check, but it's really not that easy to come up, especially if you never did it. So I like constants and Rust style, so I will just rename this thing to next, and this will be just my real right, and this is also right. So should work. Hallelujah! Look, as simple as this. We have binary expression, and then not a binary expression. Let's see if I'm happy for a right case. So we have a binary which has a numeric value 1 on the left, plus token, and on the right we have another binary expression, yay, which has on the left it's 2, and then on the right it's 3, and then again another right operand of the root expression is the 4. Yay, this is amazing! But it has only one problem. Look at this. I remember it. Currently our parser has a binary expression which always must start with the plus expression. Always. That means we can parse multiplication, but only as a nested expression in a plus. So if I remove this, it will crash. It says, oh my god, again, mul token, I don't know what to do with this. Why? Because my binary expression first calls plus expression, and plus insists that it should be always plus, which is kind of fine. Let's fix it. And we fix it, making binary expression to also know about the multiplication. So we have the head, which is this thing, and we need to first check if it's a multiplication and fold it. Then it gets the head and will fold all the multiplications and return a node, which will become a left node for the plus expression, and it gets it as left. Should work. Worked last time. Boof. Unexpected character at source 110. Okay, where? Oh, interesting. Wow, of course, yes. Semicolon. I saved in formatting. Okay, so it works. It's a binary expression and multiplication. Everything is fine. Super. Not that complicated, right? Yes.
It is.
It is, but in the other, from other perspective, it's not, because if you coded folding things like parsers before, this is a very obvious way. So you develop an intuition about context and about nesting things within things within things. So if you really want to practice recursion in a complicated and meaningful way, try to parse some language which grammar you know. This is why I've chosen JavaScript, because I know it, I feel it. I don't need to read the specification much. I just use my guts. And then this is it. Amazing?
It is.
What else I wanted to add is this strange notation. When you have multiplication expression, you give the head, and you might think that it would be really good to return here null when it cannot parse. But as I probably wrote, no, I just deleted this thing. I wanted to have two matchers. One matcher as this thing is a matcher which already gets its context. It's like it's not exactly look ahead, but very close to it. So instead of trying to look 1 or 2 tokens in the future, it gets 1 token at a time, and each token progresses the parser 1 step. So some of the matchers get the current token and return it back when they cannot fold further. And this is an expression. A good example is an expression. Another type of matchers is actually the maybe matcher, which tries to parse the current token, and it has 0 context, and it can be one of many, so it returns nothing. Actually, I wanted to return null here and here to express this. So it is kind of maybe matcher. It matches one thing or multiple things. If we continue parsing, writing parsers, this thing will actually give more, much more tokens. But if it doesn't, it returns null, and something which called it can continue parsing the current token. So these are really different. This is why this one doesn't return null, because if it did, I would need to do things like this, const temporary 1 equals this, if not tmp1, then tmp2 equals probably this, and then I need to do something. So it's a nested decision making based on temporary expressions and stuff. While this wonderful trick which I've seen in this book about how people write pure functional parsers In Haskell, they use this, probably they used it, it was like 2 years ago. Maybe something just clicked in my head. I think it is from this book. But they use this, I'm trying to parse the current thing, the current context. If I cannot, I give the context back to you. In our case, if multiplication cannot progress, it just gives back the context, in our case only one token, back to this one. If it would be head 1 and head 2, it will return a tuple of head 1 and head 2, so that plus expression can continue. Or maybe it will be something different, I don't know actually. But currently I progressed into making the language Turing complete with only one token as a context, so only one look ahead-ish token. Yeah, this is what I really love about this approach. It's readable and it looks like a regular expression. You give the context, kinda the cursor, you think of this as a cursor, and you have some group of things to match the cursor, like A to B, A to Z, and then it is nested. This is what regular expressions cannot easily give in another parser, subparser, in another set of matchers, which would be amazing to have as a recursion also in regular expressions, but thanks God we don't have it. Otherwise we will have not only one problem when we add regular expressions, but n problems. So yeah, finally I believe we reached the point when it is cool. What do you think, Olie?
It is cool. Yeah. Well, for me, it will take a bit of time to understand fully.
I believe we should switch. So that was like a really stretching goal to finish the parser. I believe we should just start re-implementing Node.js together. It's way easier. What about event loop? Or what else? What about promises? Oh yeah, remember promises? We started with promises. Yeah,
I remember.
maybe promises. Or maybe something easier.
Promises,
So
yeah, that would be nice.
thank you people for staying with us. I hope there in the future COVID is beaten and you can go outside without masks. Currently we can't. But finally we can visit each other and record something together. Yep. Ciao, Oli.
Ciao, Peter.
Bye bye, people.